Hi everyone and welcome to the learning curve. In this video we'll be looking at proportionality, which is a very common topic that is done in secondary schools. The below graph summarizes the relationship between the number of miles walked and the time taken in hours by Angel in walking to school. Firstly, we are going to identify what the dependent variable is and what the independent variable is. The dependent variable, which always goes on the y-axis here, is influenced by the independent variable, x. In this problem, the dependent variable is the number of miles walked, which depends on the number of hours that Angel spends walking. So the hours or time spent walking is independent variable, and the more Angel walks, then the more distance he will cover. So that is why miles, which is our proxy here for distance, is the dependent variable, and it's dependent on time or hours spent walking, which is normally an independent variable. So we have this graph that shows a positive relationship between hours spent walking by Angel and the number of miles covered by walking. We know that this is a positive relationship because the graph, this green line that shows the relationship between x and y, slopes upwards from left to right. So it slopes upwards from left to right, so we know that this is a positive relationship. It's a positive linear relationship, which means that the more hours that Angel spends walking, it is the more miles he will cover. In other words, both variables increase together. When two variables increase together or decrease together, meaning that they move in the same direction, we classify that relationship as a positive relationship. However, when two variables move in opposite directions, such as when the price of a product goes up, holding all other things constant, people buy less of that product. So those two variables, price and purchases, would be moving in opposite directions. So that would be an example of a negative linear relationship, in which case the graph would slope downwards from left to right. But this is a positive relationship. Here we are asked, does this graph represent a proportional relationship? And our simple answer to this is yes. Any graph whereby the y-intercept is 0, that is, where the graph passes through the origin or starts at the origin. Once the y-intercept is 0, as in this case, the y-intercept here is 0 because the graph will be passing through 0. Then, once that is the case, then the relationship between x and y is proportional. So yes, this represents a proportional relationship. And the reason that this represents a proportional relationship is simply because the graph has a y-intercept of 0. So because the graph has a y-intercept of 0. If the y-intercept is not 0, then the relationship is non-proportional. Okay, so this is definitely a proportional relationship. And the reason again is because the graph passes through the origin, the graph being the green line. All right, so this is a proportional relationship. Now we're going to find what is called the constant of proportionality. And the constant of proportionality basically describes the ratio of change in y divided by changes in x. So the constant of proportionality, which is the slope, is going to be equal to, we can simplify this by dividing y by x. And it represents the slope. So what we can do to find the constant of proportionality here is simply to identify any point on the line, any point at all on the line, and find the x value and the corresponding y value. Read the y value and the corresponding x value from the graph. So for example, I'm just going to use this point. Any point you choose will give you the same answer, as long as you read the x and y values corresponding to that point correctly. So what is the x value at this point that I have chosen? 3. And what's the corresponding y value? 6. So k, the constant of proportionality, is just going to be 6 divided by 3, which is equal to 2. So the value of k, the constant of proportionality, is 2. And what this means is that for every 1 hour that is spent walking, 2 miles are covered. That's what this would mean. For every 1 mile spent walking, 2 miles are covered. So the relationship is therefore considered to be proportional because there is a fixed relationship, a fixed ratio or relationship between the x and y values. That is, in this case, for every 1 hour that Angel spends walking, he covers 2 miles. And as I indicated, it doesn't matter which point you chose. If I chose this point here, look at the x value, 1, and the y value is 2. So I'll be dividing the y value of 2 by the x value of 1, and that would give us 2. So the constant of proportionality is 2. Now we're asked to write the equation that shows the relationship between distance traveled and time taken. In general, the equation, a linear equation, can be written as y equals kx plus b, or y equals mx plus b. They are the same things, just different symbols. This is the standard form of a linear equation, and we know this is a linear equation because a straight line describes the relationship between x and y, the straight line. So y is equal to kx plus b, or y equal mx plus b. M in this equation here, y equal kx plus b, k represents the slope while b represents the y-intercept. In this equation, y equal mx plus b, m is the slope and again b is the y-intercept. So they are exactly the same. So the equation here, substituting the value that we got for k, which is the same value for m, which is the slope, which describes the change in y for every 1 unit change in x. That's what the slope tells us. How much does y changes? How much does the y variable changes for every 1 unit change in x? And we have found by dividing y by x here that the constant of proportionality is 2, which means that for every 1 hour that Angel spends traveling, that is for every 1 unit change in x, he will cover 2 miles, which is y. So the equation here would simply be 2x plus the y-intercept is where the graph cuts the y-axis. Here the green line cuts the y-axis at 0. So the equation is 2x plus 0, or simply y equals 2x, since any number added to 0 will give you back that same number. So this is the equation of this line, which is a proportional relationship as we described, because a relationship between two variables is proportional once the value of b, the y-intercept, is 0, as in this case. That takes care of that. Now let's look at number 2. We are told that the below table shows the distance in miles covered by James and the time traveled. So we have a list of times here in hours and we have the corresponding distances. For example, when 5 hours are covered in traveling, 50 miles are covered. When 15 hours are covered in traveling, 150 miles would have been covered as a result. So our x variable here is time, which is the independent variable, and the y variable is distance. We are asked, Does the above table show a proportional relationship between distance traveled y and time taken? So, to simply find out whether there's a proportional relationship, all we need to do is to divide each of the y values by the corresponding x value. And if they are the same, so distance is always dependent on time, so distance will be assigned y, the dependent variable, and time is always our independent variable x in these kinds of relationships. So this is very simple. What we're going to do here is that we're going to simply divide to see if the ratio between distance and time is the same throughout the entire table. So let's divide 50 distance by time 5, that gives us 10. And let's divide 100 distance by time 10, and that gives us 10. Looking good so far. Now let's divide 150 by 15, and that will also give us 10. And let's now divide 200 by 20. There we go. And that will also give us 10. So because we have a constant ratio of distance to time, it means that the relationship is proportional. So yes, it's proportional. This is another way to determine if the relationship between x and y is proportional, is by dividing y by x throughout a data set. And if we get the same value, then yes, it's proportional. So yes, and the reason is because the ratio of x to y is the same, because there's a common ratio of x to y, and this common ratio of 10 means that for every 1 hour spent traveling, 10 miles are covered. That's how you interpret this. So yes, there is a proportional relationship, and it is because there is a fixed distance covered. There's a fixed distance covered. It's a fixed distance covered per hour. There's a fixed distance covered per hour, and that is 10 miles per hour. So because of this, we say the relationship is proportional. This 10 is found to be constant right throughout the entire data set, and we found that by dividing distance by time right throughout. And the final question is, write the constant of proportionality and the equation that describes the relationship between distance traveled, which is the dependent variable, and time taken, which is the independent variable. So we know that the equation of a straight line is y equals kx plus b, right? Or y equals mx plus b. Same thing. The m and the k are the same values. They are just the slopes or constant of proportionality. So in this case, k, we already know the value of k. K is 10, which is the constant ratio of distance to time, as found earlier here. So k is 10. It's just found by dividing y by x, as I pointed out earlier. So in each case, y divided by x gives us the same value of 10 throughout the data set. So this will be 10x. Now because it's a proportional relationship, then the y-intercept we know is going to be 0. So the equation is just 10x. Y equals 10x, where k is 10. And that concludes this illustration of proportional relationships and how to generate the equation for proportional relationships, how to identify proportional relationships, and how to interpret and articulate proportional relationships. Thank you for your time. I hope you found this video to be extremely simple and useful, and that you will continue to tune in to the learning curve for much more as we continue our indulgence in the world of mathematics. Remember to like, share, and subscribe. Thank you.